In this video we look at box plots. So box plots are a graphical way to identify skewness in data and also identify outliers. So box plots, are sometimes called box and whisker plots, are ways of displaying the distribution of data, and it uses 5 numbers. We have the minimum, the maximum, the first quartile, the third quartile, and the median. So a box plot looks something like this, and you can see the ends are your minimum and your maximums. And then the box in the middle, you have the lower quartile or the first quartile, and the upper quartile or the third quartile, the outsides of the box, and then the median is somewhere in the middle. So here are some examples of box plots. And you can see they can be represented both vertically or horizontally. So how do we construct one? Well, we need to find those 5 numbers. So start by finding the median. So remember, the median is the middle value in a data set. So in this case, it would be halfway between 21 and 31. So the average of 21 and 31 is 26. So there's our median. Next, we look at the upper half of the data and essentially divide it in half again. So here, the upper quartile would be 58, halfway through the upper half of the data. Next, we look at the lower half of the data and find the median of the lower half. And so the lower quartile is 18.5. So notice how the quartiles divide the data into quarters. Here we had 8 numbers, and we've divided them into 2, 2, 2, and 2. Or the lowest 25%, the next 25%, the next 25%, and the next 25%. That's how you find your quartiles. So once you have your lower quartile and your upper quartile, you have the ends of the box. So the 18.5 and the 58 give you the ends of your box. And the 26 is the median, so that is somewhere in the middle. And then we have the maximum at 60 and the minimum at 2. Notice this particular data set has some skewness to it, as the 26 is not exactly halfway between the upper and lower quartiles. If data was truly symmetrical, that median would be really, really close to the middle of that box, but it's skewed a little bit left. 26 is much closer to 18.5 than it is to 58. And so that's how you construct a box plot. Now, a modified box plot is the same idea. We have those same 5 numbers, the minimum, the maximum, the lower quartile, the upper quartile, and the median. The difference with a modified box plot is that if we have outliers, remember, outliers are values that are very extreme, and so what we do in a modified box plot is we sort of pull those outliers out and denote them with an asterisk. What we use to denote outliers is that we look for values that are more than 1.5 interquartile ranges away from the outside of the box. So we'll talk about IQR here in just a second. So suppose we have this data set. So notice again, we put these in order. That's the first step when you deal with a box plot. Put these in order. So I need the median and the upper and lower quartiles. Okay, so the median would be that 5.4 right in the middle. And then if I look at the lower half of the data and the upper half of the data, and again divide those in half, I get 6.3 and 5.1. So there's my first, second, and third quartiles. So the interquartile range is the difference between the third quartile and the first quartile. Another way to think of it is sort of the middle 50%, because you can kind of think of the first quartile as the 25th percentile, the third quartile is the 75th percentile. So we're looking at that 50% in the middle. So if I take that in this case, 6.3 minus 5.1, it's 1.2. So 1.5 times that gives me 1.8. So any value that is more than 1.8 units away from the upper quartile or lower quartile would be an outlier. So in this case, 14.9 is an outlier in this data set, because it is more than 1.8 units away from 6.3. So our box plot here would look something like this. Notice my box. I have my lower quartile, my upper quartile, and then the median. But notice here my maximum value, I've pulled that out with an asterisk, because that 14.9 is an outlier in this case. The other end, we still have 4.3 as our minimum value. But this would be a modified box plot. If I had just drawn a line out to that asterisk, it would be a regular box plot. Modified box plot means we pull out outliers. It helps us identify outliers in a data set. And so here's an example I found on the internet, Oscar-winning actors, their age for females and males, and you can see there were some outliers, values that were more than 1.5 interquartile ranges away from the box. And so that is box plots and modified box plots.